Number 6 and number 7, the precise definition of the infinite limit. We learned the infinite limit in the other section. Whenever we have the infinite limit, we have a vertical asymptote. So in example number 5, we use the definition number 6 to prove that the limit of x approach to 0 of 1 over x squared equal to infinity. Okay, so this is a, and 1 over x squared is the function f of x. So before we begin, let's recall from algebra that if we have a greater than b, then the reciprocal 1 over a will be less than 1 over b. And of course, a greater than b, and it will be greater than 0. Then this could be true. And of course, if a less than b, then the reciprocal 1 over a will be greater than. Okay. Okay, so they said that we use the definition of number 6. So whenever we do the proving, we have 2 steps to do. First of all, we need to identify the delta. So we want to show that if, and then we copy that style, right? If 0 less than the distance from x to a, so a is 0, less than delta, then we have the function f of x, which is 1 over x squared greater than m. And then we will begin from this, continue from that, and we want our goal is to get this. So to get absolute value of x, okay, less than delta. So we will compare the delta and the m to see the corresponding between them so that we can choose the delta. Okay, so this is mean that I do the reciprocal for both sides. Okay, so I use this. If I reciprocal both sides, so I will get x squared, and it will be less than 1 over m. Okay, then we take the square root. This is true if we take the square root for both sides, and the square root of x squared is the absolute value of x, and this is what we want, right? So we want to have absolute value of x less than square root of 1 over m. So that is mean that we will choose delta to be square root of 1 over m. Okay, so given, so this is step number 2, and given that for every m greater than 0, we will choose a delta equal 1 over square root of m. This is the same thing as 1 over square root of m. Okay, so then if we have 0 less than x minus 0 less than delta, then we have 1 over x squared, and we want this to be greater than m in the future. Okay, so this is what we want. And what do we use? We will use from the statement. Keep in mind that we will use this statement. This statement is the same as the absolute value of x less than delta. Okay, so 1 over x squared, this is the same as 1 over absolute value of x squared. And so if I have absolute value of x less than delta, I do the reciprocal for both sides. So this is the same as 1 over absolute value of x greater than 1 over the delta. Okay, so then I square this, so I will get this. So greater than 1 over delta square. And then it's equal, because we choose delta to be 1 over square root of m, so let's go ahead and plug it in. Okay, so we need one more step. So let's erase that for a little bit. And this is equal to 1 over 1 over m. And 1 over 1 over m is m. Okay, so we just finished proving that the limit of 1 over x squared as x approaches to 0 is infinity.